Hi guys, in this video we will learn about repeatable read isolation level. This isolation level provides all the guarantees that were provided by the read committed isolation level, but also ensures that the problem of fuzzy reads is avoided. So, repeatable read isolation level is free from the issues of dirty read and also fuzzy reads. In repeatable read isolation level, a single snapshot of data is used for the whole transaction. That is, the first time a select query is fired within a transaction, a snapshot of the database is recorded, and that same snapshot is used to answer any further queries within the same transaction. However, in read committed isolation level, each select query makes use of a different snapshot. This is how the repeatable read isolation level actually avoids the problem of fuzzy reads. Let's try to understand the repeatable read isolation level and how it solves the problem of fuzzy reads by taking an example. Here we have our previous setup, the user table with A, B and C as the users. A has an age of 20 and B and C are yet to be born and have age of 0. We have two transactions, transaction 1 and transaction 2. So if you will look closely, this setup is actually pretty much same as the setup we had in our example of read committed, where we have described what actually is the problem with the fuzzy reads. So we are actually taking the same example to show you how the problem of fuzzy reads is actually avoided in the repeatable read isolation level. Okay, here we have not explicitly set any of the isolation levels in the transaction because repeatable read isolation level is also the default isolation level that is used by MySQL. So we don't need to specify any of the isolation level before starting the transaction. So here I have not specified any isolation level before starting the transactions. So these two transactions, transaction 1 and transaction 2, will actually make use of the default isolation level, which is actually the repeatable read isolation level, right? So directly we have a start transaction statements in both of the transactions. So let's see what transaction 1 is actually doing. Transaction 1 has two update statements. One is the update statement that updates the age of record B to 20, and another is the update statement that updates the age of record A to 10, and then finally the transaction commits. In transaction 2, we have a select statement that actually gets the age of user B, and it actually assigns the age to a variable BAge1, and we have another select statement that gets the age of user A and assigns the age to a variable AH, and then at timestamp T8 it again fires the select statement to get the age of user B and assigns the age to BH2. Once these three statements are completed and it has got all the variables assigned, it fires the update statement at timestamp T9 to finally update the value of user B to the sum of BH1, AH, BH2, and then finally the transaction actually commits. So in the previous example where we actually have seen the problem with the fuzzy reads, there we have seen that these two statements, the select statement that is fired at timestamp T3 to get the age of B and the select statement that was fired at the timestamp T8 to get the age of B, these two statements actually return different records. The statement fired at T3 returned the age to be 0. However, the statement fired at T8 actually returned the age to be 20 since the transaction 1 had actually been committed. But here, since we are actually using repeatable read isolation level, and we have seen that in repeatable read isolation level, what happens is that whenever the first select is fired, a snapshot of the database is taken and the same snapshot is used for all of the queries. So at time instant T3, a snapshot of the database would be taken, and on that snapshot the age of B would actually be recorded as 0 because none of the transaction has actually updated that record and committed. Okay, so both the statements, the statement that is fired at T3 and the another statement that is fired as T8 to get the age of record B, both will actually return 0. Yeah, so the problem of fuzzy reads is actually avoided because T8 is unable to see the changes that has been made by transaction 1 even though the transaction 1 has committed. That's because this transaction T2 is actually making use of the same snapshot that was taken before the transaction 1 has committed. So both these queries, the query fired at T3 and the query fired at T8 timestamp, both will return the age as 0. Hence the problem of fuzzy reads is actually avoided in repeatable read isolation level. Okay, we have the same question. What will be the updated value of records A, B and C after both the transactions has actually committed? Yeah, so I will again request you guys to please pause the video and get to the answer by yourself, and then we will see what is actually the correct answer. Okay, so here we have that after these two transactions has actually completed, the age of record A is set to 10, the age of record B is set to 20, and age of record C is set to 20. Yeah, this seems pretty much obvious as A would be updated to 10 by this statement, the T5 statement in transaction 1. B would be updated to 20 by T4 statement in transaction 1. And since we have already seen that B age 1 will return the value of 0, A age would actually return the value of 20. Same reason, it uses the same snapshot that was taken by the first query. So even though T1 transaction has committed, still the age returned by the A age would be 20 itself, and BH2 variable would also return the age as 0. So the final age for C would be 0 plus 20 plus 0, which will actually return 20. Yeah. Hope you guys have understood the repeatable read isolation level, and in the next video we will move on to serializable isolation level.